Okay, a very good morning, everyone. Welcome to this session on Python scripting in QGIS. This morning we have with us our guest faculty, Shri Nilay Nishant, Scientist Engineer SE from Northeastern Space Applications Center, NISAC, Department of Space, Government of India, Umiam, Meghalaya. He has over more than a decade of years experience in space technology applications and research. He completed his master's degree in remote sensing from BIT Mesra and bachelor's in ECE from University of Pondicherry. His research interests include geospatial big data analysis, analytics, e-governance, artificial intelligence, and deep learning on Earth observation data. He has developed more than 25 governance applications for various user departments in Northeast India. He has published about 20 research papers in national and international journals and conference proceedings. He has been awarded the prestigious National E-Governance Award 2022, Northeast Award 2023, and AGI Award 2024 for his contributions in the domain of e-governance application development. So I welcome Sri Nilay Nishant. Thank you very much for joining us today with this session. This training program, we have designed it to be a very basic course. So in the first 4 days, we introduced the participants to the GIS and remote sensing technologies, making use of QGIS. And then we started working on specific applications like catchment delineation, LULC mapping. So please, now it is the floor is yours. Please deliver the today's topic. We will be sharing the recorded session with and as well as the presentation slides with the participants after the completion of the training program. Yeah, thank you.
Uh, Thank you, sir. I hope I'm audible. Is it clear?
Yes, yes, it is
great.
clear.
Okay, thank you. So I'll just share my screen. Welcome, everyone. Today we'll be going through two parts of the session. On the first part of the session, we'll go through the basics of PyQGIS. That is how the Python API interacts with QGIS. We'll learn about basic scripting of PyQGIS. And then on the second half of the session, we will try to explore in more detail like how we can develop a very basic plugin on QGIS. So without any further delay, let me just share my screen. So yeah. So I hope the slides are visible to all.
Yes, yes.
Okay, great. So before we start, just we would want to know like why do we want to go for Python scripting with QGIS? Like what are the things where we can use such an application? The first thing that you can do uh, on QGIS with Python is you can issue some basic commands from the Python console. So QGIS comes with an integrated Python console, wherein if you have to basically link a couple of processing algorithms, so you can directly link those algorithms, load the data, write the data directly using Python command. Secondly, you can also run a Python code when QGIS is automatically starting. So in an event, if you want some data to be loaded directly when you want to just start your QGIS application, something like the forest fire information that comes from NASA's firms portal. So if you want it to be downloaded dynamically and loaded onto the QGIS platform, such an operation can be done. Uh, QGIS also has a range of functions uh, to basically implement something like a field calculator. In field calculator, you have a range of functions to calculate area, to calculate the coordinates, X and Y coordinates, and all these things are there. But if you want to write your own custom function, therein you can use this functionality of Python to actually write your own custom function using PyQGIS. There's another very interesting component when it comes to QGIS and Python integration. This component is basically called as actions. So actions are basically triggered when you click on a particular layer. So usually when you are clicking on a particular layer, you are expecting that you can either select a particular layer, or you can uh, either go ahead and get the feature information of that particular layer. But what if you want to run some sort of a Python code that will edit a certain functionality of that layer, or that will run a certain algorithm on that layer the moment if I click that layer? So such a function can be written via something called as QGIS actions. These are very useful when you are doing some sort of a QC, grid-based QC for your data set. So on click of a button, on click of the grid, you can basically change your grid status QC to yes or no dynamically. So this can be achieved using something called as QGIS actions. Now, all of you must be aware by now that QGIS has a range of processing algorithms, and these processing algorithms can be directly accessed using Python console in QGIS. So we'll be seeing in detail how to run QGIS processing algorithms from this Python console in QGIS. Another interesting thing that you can do with Python in QGIS is you can run QGIS in a headless mode. Now, what do we mean by a headless mode? By headless mode, we mean that we need not even start QGIS. We not even like initiate the GUI of QGIS. We can basically run something like a cron job or a scheduler. So consider a scenario where daily you need to prepare something like maps for water level uh, on different river stations across the state of Maharashtra. All right. This requires a couple of steps. The first step would require something like downloading of the data. Second is like plotting the non-spatial data onto a spatial data platform, preparing the map, and finally exporting the map. So this kind of a scheduled operation can also be executed using QGIS in an headless mode for data processing and output generation. In this case, you need not start QGIS. You can basically uh, run a shell script of QGIS. So every morning, probably at 6 or 7 a.m., your data will be downloaded automatically. QGIS will automatically download your data. It will plot the non-spatial data into spatial data sets. Then it will create the relevant symbologies and also export the map. So this kind of operation can also be carried out using QGIS. Finally, yeah, hello.
Yes, sir, sound is not clear.
Uh,
No, it is clear. Maybe you have to check the network at your
I'm
end.
not audible, sir.
It is clear everywhere.
Hello.
is it clear? Hello, can you hear me, ma'am?
It's clear, sir.
It's clear, right? Okay.
Yeah, clear for us.
Okay, great. So I'll just go ahead. Finally, there are two or three new things in this. That is, you can create your own processing algorithms. QGIS has its own lists of processing algorithms. If you want to go beyond that, if you want to create your own processing algorithm, you can go ahead and create your own processing algorithm and export it as a plugin also. So this is how these are basically the functionalities that would that you can enhance the power of QGIS and you can use it with Python plugins. So now coming on to the major components. So if you see how this QGIS and PyQGIS are structured, so it comes with, you have to understand three basic concepts. The first one is what is Qt, second one is what is PyQt, and third one what is PyQGIS. Now Qt is basically a widget based toolkit. Okay, whatever we see in QGIS, it has actually been developed using Qt. So it is a tool to actually design your user interface. It is a free and open source tool. You can basically create drop downs dynamically using this Qt platform. PyQt is basically an interface of Qt with Python. So if you want to link the Qt, the user interface that you have created with the Python code, you have to use PyQt. And third and the final thing is what is PyQGIS. So PyQGIS is basically an API. Okay, QGIS has its own functionalities, and if you want to access all those functionalities using Python, so you will have to use something called as PyQGIS. Okay, so what we will learn today is fairly simple. We'll learn how to create a simple hello world. Then we'll learn how to load raster data, how to load vector data, uh, how to run processing tools, how to basically chain the processing algorithms, write your own processing script, and write your own processing plugin. So these are some of the concepts that we'll go through today. So let's just get started, and you can follow along also, but after this I'll also be sharing you the data packs which you can use. But before we get started, let us just go ahead and understand how does this interface look like with QGIS. What is the interface with reference to Python? So all of you must be aware of like this kind of user interface when it comes to QGIS, wherein the left portion is basically the layer tree. The center section is basically the map, where the map is loaded. And on the right, we have something like where all the processing tools are coming. Now, if you see here, there's a button called Python console. If you just click on this button, you can actually see that there's a console that opens up. So this is where you actually write your Python codes for QGIS. All right. So on the left here, you can see there's a clear console button. On the right, you have a run command button, and then you have an editor also. So what you can actually do is actually you can go here and just go here and type print hello world. So this would actually type your hello world operation. You can use this clear button to clear your outputs. Now, since this is a basic course, so before we dive into all the uh, like details of PyQGIS APIs, I would also like to go into some basics. Then I'll dive into the PyQGIS APIs. So this is basically the editor. Herein you can actually write your Python code. So whatever I've written as single command based. So whatever you write here is a single command based. You can write it as a script here. So you can also go ahead and write print hello world here. And if I click run, so you get the run here. Then you can also go ahead and type mm, x equal to 1 and print x. So this would actually print hello world and 1. So this is how you can actually go ahead and utilize your Python console interface to write your Python scripts. Now, there are few things that we would like to go through first. The first one is we'll go through something called as variables and data types. Okay. In case of Python, there are basically 2 or 3 different types of data types. The first one is called as an integer data type, wherein you basically store all the integer variables. So x here is a variable. I stored the value 10 here. So this is an integer variable. Y would be like 34.2. So this would be like a floating point variable. And then comes a string type of variable, wherein something like name. Okay, name you can store it as Ramesh. Okay, so this is your string variable. Then you have something like list. Okay, so wherein you can store numbers. Numbers would be stored as an array. So I can go ahead and store 1, 2, 3, 4, and 5. So this is your list operations. And finally, you have something called as uh, uh, a dictionary or a key value pair. So let us just go ahead and print all these and see what are we able to see in the console. So if I go print x, okay, print y, and numbers. So you can see here, this gets printed as an integer value. This gets printed as a floating point value. Then this gets printed as an array. Finally, we have something called as a dictionary. Dictionary would be something like a person with the details. So person with the details is name. So dictionary is written as this. So you have something like name, John, okay, and followed by age. Age is 30. So now if I go ahead and print the person details, so I should be able to see, sorry, it was, so I should be able to see the details of the person. Finally, we would also want to know what is something called as conditions or iterables. So basically, in Python, you can also do something called as a conditional or control workflows, wherein you can give an if condition. If value of x is say less than 20, then print x is less than 20. All right. Else print x gt 20. Okay. So this basically shows you that if I execute this now, it prints x is less than 20. All right. In QGIS, there's another button here. You can ideally go ahead and click on this button called comment. So this would comment all the codes that are not required to be executed. So now I'm commenting everything else. I'm clearing it. And now you can see it prints x is less than 20. Okay. One last thing I would like to show here is something called as iterables. So whenever we are reading our geospatial data sets, there are a lot of rows in the geospatial dataset. Each GIS layer has a lot of features, and each features are considered as rows. So we are always required to iterate through those rows. So learning how to iterate through that rows is also important. For that, you will also need to know something called as a for loop. So you can basically go ahead and type here for I in range 5. Okay, if I go ahead and print I, so it will go ahead and print all the values between 1 to 5. Sorry. Okay, so it goes prints from 1 to 4. So this is how you can actually iterate through the different values. So similarly, whenever you are loading a geospatial layer and you want to iterate through those geospatial layers, you can go ahead and iterate through those geospatial layers as a iterable. Now let us just go ahead and start interacting with our QGIS windows. So QGIS basically comes with something called as QGIS classes. Okay, and one of the popular class in QGIS is called iFace. So any interaction that you would want to do with QGIS, you would actually need to interact with something called as iFace. Okay, so if I go ahead and type iFace, okay, iFace dot message bar, okay, dot push and type what. Okay, so you see here on top there's an hello world option that gets pushed in here. Okay, so this is the first thing that you need to understand, that how we are going to interact with QGIS and iFace. Now, how do I basically load a vector layer? Okay, so to load a vector layer, it requires something called as a QGIS class called as QGS vector layer. Okay, so I can give a vector layer. I can declare a vector layer as vector underscore layer equal to QGZ vector layer. Then the first argument that will go here is the path of the vector layer. So in this case, I already have some vector layer that is available with me. So let me just go ahead and copy the path of the particular vector layer. So let us go and load data. Sorry. Yeah. I have a state boundary of Sikkim. So I'll just copy as path. I'll just paste it here. You have to ensure that all your slashes are forward slash. You the Python commands don't accept backward slashes. So just change it to forward slash, and then the next argument in this is basically the layer name, how we want to display this layer name. So I would basically give it as Sikkim vector layer. Okay, and finally the driver using which we will load this data. Okay, so this is how you can actually declare a vector layer. Now the next step is basically to add this layer onto the QGIS map interface. Okay. So how do we do that? It's a fairly simple process. There is an instance called QGIS project. Okay, you have to create instance of that project. Instance. Okay, and then you have to run a command dot add map layer. Okay, so this is something like an we are calling this is QGIS vector layer class. We are calling the object of this class and we are adding it onto the map. Sorry, QG is it the small spelling mistake. So you can see here the Sikkim state boundary gets loaded onto the map. Okay, so this is how you can actually go ahead and start loading the different QGIS vector layers. You also have an option to load raster layers. So I can go ahead, copy this. I'll add raster layer. Okay, the same thing. Now you just need to change the path. I'll just check where's my raster layer. So I also have a DEM boundary. So I can go ahead and load a DEM here. So DEM is in the TIFF format. So I'll just DEM dot TIFF. So this is DEM is under TIFF, and the driver is basically uh, uh, the backend that will be used to load this data. So to load raster data, it is GDAL, and to load a vector data, it is OGR. Okay, if you click this, you have vector layer loaded, but I'll have to load the raster layer also. So I'll just need to copy this and paste it here, and I'll just load the raster layer here. Okay, so okay, 1 second. So this is how you can actually load the different layers. Fine. Now we would want to go ahead and do some other analysis. Something like I've loaded a layer. I want to basically perform some sort of a operation on this kind of layer. Like I want to calculate hillshade on the raster layer which has been loaded. So this is the raster layer. I want to perform an hillshade operation. How do you do it? So the standard operation here is basically I load hillshade. Okay, I go ahead, open the hillshade, and I click run. So this would basically calculate hillshade and give me the output. Now, how do I basically link this hillshade onto the processing algorithm or processing toolbar? So this is the next step. In order to perform any kind of spatial operation on QGIS using Python console, you can directly call these processing algorithms from QGIS processing window. Okay, so how do you call this? You can go to processing menu. Okay, this is the processing tool. If you go to history, you can see the different algorithms that have been executed onto this PC. And now I can also see that there's a processing.run that has just now been executed. Okay, so in that case, I'll just copy this. Okay, and I'll paste it here. Now this is the tool that can be used to run all the processing algorithms. Okay, so here I'm running a processing algorithm, that is hillshade processing algorithm. The input data is the data location. Okay, this is the input data. This is the Z factor. All right, and this is the output data. Okay, it is currently storing it as a temporary file. All right, so this is how you can actually run this operation. Now, in order to basically store it as a temporary output, you can, instead of this, you can simply go ahead and type it as tempo underscore output. So this is how you can go ahead and type it as temporary output, and the moment you click run, this would actually run this algorithm, but it will not display the output. So in order to run it and parallelly display it, you would need to modify this processing.run as processing.run and load results. Load results. So this is how, once you click it, so it loads the vector layer, and also it will actually load the hillshade output. So this is how you are able to load the vector layer and load the hillshade dynamically. Fine. If there are any doubts, we can keep clearing the doubts on the way. Okay.
If you have any query, please post in the chat window. And towards the end of the session, you can we will allow you to speak and pose your questions.
Sure. So now the next step is basically, if you have say 2-3 operations that you need to do together, how do you do that? Okay, so this is the next step, that is basically chaining up of these processing outputs. So you can also do that over here. I'll show you show that step by step. Okay, so let us just load a few data. We'll try to see the exact use case scenario, why we want to do this, and then we'll go ahead and try to implement a processing algorithm that will help us understand how do we implement it. So let's just go ahead and load few data sets. So I have a few data, that is, one is the the district boundary of Sikkim, and I have some NDVI layer. So if I go ahead and see this NDVI, I have basically 3 bands in this NDVI, that is basically corresponding to 3 dates. I have stacked it and kept it. Now I want to know what is the basically the zonal statistics at district level, but I also want to know for each and every year. So the first band was for 2018, the second band was for 2019, the third band was average NDVI for 2020. QGIS gives you a tool to perform zonal statistics. You can go ahead and search for zonal statistics over here. Now, once you click on zonal statistics, you can select the raster layer, and you can select your district boundary, and you can select the statistics that you want to calculate. Click OK. I just want to go ahead and calculate probably the average NDVI. So I'll just go ahead and click this click OK. Now what is happening? If I click run, okay, 1 second, let me just, there's some issue here. Okay, if I, okay, so the mean gets computed and gets added here. Okay, but now what I actually want is I want for different timestamps. So I want this data to be computed for say 2018 separately, then 2019 separately, and then 2020 separately. Okay, so how do you ensure that this output comes in like in the format desired? So I have an output format. I can show that output format so that you'll have a better clarity. So this is the output. I load it. I can see that layer 1 some, layer 2 some, layer 3 some. Okay, so this is actually I want to achieve. To achieve this, I'll actually need to do this operation multiple times, right? So now I'll have to take this again. Okay, the raster layer would be NDVI, and now I'll have to take this L2. Then again I'll have to go for average. Click OK, then click run. Okay, so this is like a multiple process operation. Right? So in order to do this, aggregate it into a single operation, you can go ahead and implement something called as a chaining of processes. Okay, so for now I'll basically delete the two mean operations that I'd created. I can click save. Then basically the first thing that you need to do is how do you actually link processes or run the processes in QGIS. Okay, so to run any particular process in QGIS, you can simply go ahead and look at the history button. Click on history button. Now you can see here, this is the zonal statistics process. Okay, so for the first time, what we did was we can just create a new tab. Click on this. Now you can go ahead and start running your process. So you'll have the state boundary. Okay, I'll try to make this a little bit bigger so that okay. Then you have okay, fine. This is, you have the state boundary. Then you have the raster band and the input vector layer. So this is the first operation, right? If I run this, it gives me underscore mean. Okay, this is what I was able to achieve from running this output. Now the idea is basically to execute this step by step together so that I can get all the three outputs in a single window. So this output gets stored in something called as zonal stats underscore 1. I can store this as zonal stats 1, and the input for this vector layer would be the output of this zonal stats 1. Okay. So this is how you can actually load and chain the processes together. So now I will name it as L1 layer 1 statistics, followed by layer 2 statistics. Okay, but in order to change it to layer 2, you will have to give the band number as layer 2. Similarly, I can also go ahead and change this, add it here, add this below, and this goes, save this as zonal statistics 2, and run the output. Now, in order to basically execute this zonal statistics 1 here, pass it authentically, you need to actually pass the actual output variable. So that can be accessed using something called as zonal statistics zone. Sorry, you can take this zonal stats 1 equal to zonal stats 1, and you need to give output of this. Okay, so the output of this gets passed as the input vector layer. Similarly, you can click on this, and instead of zonal stats 1, I'll give it as zonal stats 2, and this is zonal stats 2, and this becomes zonal stats 2. So let us try and run this. Okay, there's some issue. Let us see line number 7. Zonal stats. Okay. Zonal stats. So you can oh yes, it's here. So this is how you can actually chain the processing algorithms together to link the commands and basically display it in a single workflow. Fine. So this is the second step that we were able to execute. And herein you'll have all the outputs that are linked together in a single command. Fine. Okay. So the next step is basically how do you actually run something called as a processing script. So we can also execute something called as a processing script, wherein all these outputs would be linked together and would be displayed in a single processing script. And for that, we would actually need to connect all these processing scripts together. To carry that operation, we would actually need to start understanding how the script works and what is the basic output of the plugins. So if you see here on the top, there is something called as create a new script. So QGIS gives you options to actually create modelers. It also gives you options to create scripts. So this is the button where you can actually create models, and this is a button where you can actually create some scripts. So herein you can either open a script from template, or you can go ahead and open and create a new script. Okay. So once you do this, you have an option to actually go ahead and add a few scripts. So now I'll just add scripts. So I'll be sharing this detailed handouts with you so that you can go ahead and implement these operations on your own. Let us just go ahead and zonal statistics. Yeah. You can just copy this. Right. I can go ahead and paste this command. Now, if you see here, it takes a few important things as inputs. So it takes two inputs. The first input that it has taken is the vector layer input, and the second input that it has taken is the raster layer input. Okay, and this is the output where I want to save this operation. And basically below that is nothing but the statistics that I would actually like to compute and where I would actually like to store this information. Okay, so all I need to do is go ahead and save this as probably something called as temporal zonal statistics. Okay, I save this as temporal zonal statistics.py. Save it, click run. Okay. Sorry, I think my QGIS is okay. I understood. Okay. There is a slight issue in this system. I'll just connect from another system and I'll just share my screen again. Huh? Just give me 2 minutes. Sir, I'm connecting from just another system. Just give me 2 minutes.
Okay. Now you can actually see the moment I click run, it opens up a window. Okay,
Herein, you can actually select the district boundary. You can click run, and you can also go ahead and save this output. So I can go ahead and save it as, say, final. Okay, save, click run. So it actually runs like a tool, and the output also gets saved here. And this is how you can actually, if you open the attribute table, it is actually going on the back end. It is calculating the total NDVI for different timestamps. Okay, 2018, 2019, and 2020, and returning it in a single window. So this is how you can actually go ahead and integrate the QGIS scripting operations with your this thing as a tool. So I'll repeat this process once more. All you need to do is go ahead and right click, edit the script. Okay. You can also go ahead, you can go ahead, create a new script. And then after creating the new script, all you need to do is just paste the script that I'll be sharing with you. So this is the temporal zonal statistics script. Just paste it here. Okay. And this takes in parameters of input layer. Okay. So the code for taking this input parameter is written over here. Okay. So this definition would help you create that particular input field window. Okay. Then the input parameter as a raster layer. So this is for adding input parameter vector layer. This is for input parameter as a raster layer. And then this is for adding your output as a geo package. So this basically links all these three together. And the moment you click on this, and then you have your zonal statistics 1, wherein the first band is calculated first with statistics of sum. Here, for the second band, statistics sum is calculated, and for the third band, statistics sum is calculated. If I want to change it to average, I can do that also. So all I need to do is basically change this index to 2, and I click run. And I can click on this particular NDVI boundary, district boundary, save the file to final 2, save, and click run. And it gives you the output. This is the final 2. Now if I open the attribute, now I can see I'm actually passing layer 1 underscore mean, layer 2 underscore mean, and layer 3 underscore mean. So this is with reference to scripting in Python and how you can actually like chain the operations together, how you can link the different attributes together, how you can couple the processing algorithms, how you can actually load the raster data, how you can load the vector data onto this QGIS platform. These are some of the basic tools that we actually learned today. Now I'm open for questions. Any questions I can take up? Followed by this, I'll go ahead in the second part of the session. That is where we would learn how to create some basic plugins. Okay. There are a few questions. It's easy to run. And why use? Okay. Uh, uh, See, a simple hillshade operation is easy to use via this thing, the QGIS window. That is the processing toolbox. But uh, if you want to basically run an operation such as first you want to compute the hillshade, then you want to basically clip it to a particular area of interest. So that requires a couple of steps that needs to be linked together. And doing that is basically chaining of steps or linking the algorithms together. That is where the QGIS processing algorithm helps you, and PyQGIS scripting APIs would help you, right? And like I had already said in the beginning, you can also use this operation to run in a headless mode. So, what is an headless mode? Every day, if you want to schedule a certain task, say, on top of this hillshade which you have generated, you also want to uh, see what is the water level which is being captured from different river stations. So you can also link all these algorithms together and display it as a map. I hope this answers your question. Mr. Vijay Patil is asking, can we also create content from dem by Python program? Sir, what we can actually do is we can use the QGIS processing algorithm itself and execute it using the PyQGIS API. And if you execute it using the PyQGIS API, you can very well go ahead and implement this as a processing algorithm. Any other questions?
Hello.
Yeah,
In this script, sir, we are doing means the function zonal statics for each and every bands separately.
yeah.
Each band we have write separate functions, right? So
Yeah.
can we do it after writing a function for zonal statistics?
Huh?
Can we iterate it over the different bands? Like if we have 100 or 1,000 bands.
Yeah. Definitely, you can do it. Uh, therein you have something called as this raster output, right? I'll just show you here. This raster layer has a function called as band count. Okay. So if you go ahead and now if I go ahead and type raster, we will have something called as band count. Okay. So this is a band count function, and if you see this band count, it returns band count as 3. So you can use, if you have 100 bands or even like 50 bands, you can identify this as a band count and you can iterate over this.
Okay, thank you.
Uh,
I think the question about creation of contours using a DEM, already processing toolbox has a tool. Now, if you, I think when we want to chain up the processes and when we want to repeat processes,
mm.
then we can go for scripting. Am I right?
Yes, sir. Exactly.
That is the, so because the basics, we have to start from teaching the basics. So a simple example has been shown for which tools are already there, but the idea is to how to scale up. For that purpose, it will be very useful.
Exactly, sir. Uh, how can we make this script work as a tool? with variables as input. Sir, this is actually working as a tool with variables as okay. So, are you asking about the script which I've written in the QGIS console or the script which is here? So there are two aspects to it. The first aspect is I have hard coded a few data sets over here, right? This is data, this is the raster data, and this is the hello. Yeah. So there's a raster data here and a vector data here. This is a hard coded data set. Okay. This is hard coded. This is also hard coded. All right. Now, if you want to go ahead and make this as variable, that is where you actually need to go and take this core algorithm and put it in the processing algorithms as scripts. So therein we actually created a script, and I'll edit the script again and I'll show it to you. So here is our actual logic that we had implemented. Okay, and this is where we are actually passing it as variables. Okay, so this is where we are actually passing it as variables. So we are able to load this input data as vector layer, input data as raster layer, and the output. So you are able to actually change that information into a variable based input, and you can actually run processing algorithms. Yeah, what you can do is for the data set download, I can share my GitHub repository. So you can go ahead, and for anyone who would want to perform this operation parallelly, uh, there's a GitHub repository. It goes by the name of Advanced GIS. So, let's click here. Advanced GIS. I'm sharing the link of my Advanced GIS repo. All that you need to do is actually go ahead and clone this repo. All the data set, whatever you need, is available in here in the data folder. Okay, there is another data set that is available here, plugins data. So these are the places where you'll be able to see the data and you will be able to execute. Yes. Scripting is helpful for uh, see, one process is done for different vector layers and raster layers also. So also in case of if you want to develop your own processing algorithms, so we also had written a plugin wherein we could actually train some deep learning models using QGIS and machine learning models using QGIS itself. So for that also we implemented a QI based plugin, and we were able to very successfully write a custom process that was uh, exporting and writing your own logic.
Chaitanya sir, can I ask a doubt?
Yes, yes, sir, please.
Yeah. Now, sir, we are trying to do the similar type of exercise using Google Earth Engine to
Okay.
extract the water boundary. So, do you see any difference if I work with the QGIS, and will there be a difference in case if I try to get the water boundary using this and that? Because the state boundary there we are downloading, will
Mhm.
there be a difference, or how does that? Can you comment on that? Because the source data, is it going to be same or different?
Okay, sir. One thing is what sort of operation we are trying to achieve. That is
Actually, we are trying to download the district boundary and then identify the number of water bodies and create a time series, how it is growing or how it is shrinking.
Okay, okay,
So
okay.
will that give a betterment in QGIS instead of doing it in?
Understood.
Yeah.
So, sir, QGIS is actually very good when it comes to vector-based data processing.
Okay.
Okay, and if you see all the majority of the tools that are being provided in QGIS,
Mhm.
okay, all these which are under which are with Q icon, they
Okay.
are majorly vector, and for raster-based, it goes for GDAL. Okay, uh, so for what you are doing, it
Yeah.
uh, it is better advised that you look at Google Earth Engine.
Okay.
Okay,
But the clouds create a problem. So many of the times clouds are identified as water.
okay. I think which data you're using, sir?
Sentinel.
Sentinel-2.
Yeah.
Google has recently released a new cloud mask.
Okay. Oh.
Okay, so you can use that.
Okay.
That is an AI-based generated cloud mask, and you can use that to filter out the data.
Oh,
Uh,
so
I'll
nice. Okay.
probably I'll try to find out the exact link, and in the second half of the session, I can give you the exact link of that. This thing.
And Nisanji, we will be in touch with you. We'll take your contacts from
Sure,
Chaitanya
sir.
sir.
No problem.
Thank you. Thank you so much. Very interesting.
Okay. Okay, is print layout can be scripted? Okay, that is a very good question. I can also help you out with that. Uh, the question is, can a print layout be scripted by a specific scale or template? See, actually, QGIS has a tool to export it as a print layout also. So, what you can actually do is uh, you can go ahead and type layout. Okay, if you see here under cartography section, you can actually have a print layout exported as an image. Also, you can have it exported as PDF. Okay, and you can also export it as Atlas. Now, we also wrote a model. I can show you a model. Probably in the second half of the session, I can also touch up a little on this model, wherein you can actually couple these operations together. So here you can see I'm actually downloading a file, okay, from NASA's firm's data set, okay, and I am giving an input. This input is basically the northeast boundary, okay, and I can basically select by location. So this would basically run and uh, give clip out all the forest fire locations that are happening for northeast. Okay, the output will be stored in a separate shapefile, and it will parallelly export this data as an image. Okay, and I'll probably have an image also here somewhere. I can show you that. Just give me a second. If yes, so it looks something like this. Okay, so that is what I was telling you. If you are working on some tasks that you have to do on a daily basis, that is something like you want to download this data, uh, prepare a map. Every morning you have to do this task. Such a modular output will be very helpful, and the same thing can be executed, and a print output can be generated using QGIS. So it can all be done through scripting.
Uh, can I share with them your GitHub repository, whole file,
Yeah,
advanced
yeah.
GIS?
Yeah, I've already given this. You are sharing it as a file. That way
Yeah, as a file.
yeah, that is
Because
also fine.
many of them may not be uh, aware of how to access
Okay, okay,
the, yeah.
okay. Sure, sure. Any other questions?
Yeah. Are there any other queries? If there are no further queries, you can always you can post your queries in the e-learning platform. I will get them to the faculty for clarification. So I think we can conclude the session, and we will again meet at 2:30 for the next session on QGIS plugins customization using Python. So thank you very much, Shri Nilay Nishant,
Thank you, sir.
for joining us today.
Thank you, sir.
So we will all meet again at 2:30 with a different link. I will be sharing the link.
Okay, sir. Thank you, sir.
Okay. Thank you.